Good afternoon, everybody. My name is Thomas Quinlan. I'm the Director of Solutions Architecture here in EMEA at Zscaler. Been at Zscaler for a little more than 2 years at this point. I've been working with technology professionally for about 22, and to date myself, been in computers for about 40 at this point. So I lead a team of solution architects throughout EMEA, and prior to that, I was a solution architect myself. So I've been helping companies deal with digital transformation for some time. I did over 100 architecture workshops alone last year. Today, we're going to talk about 3 key initiatives to secure your remote users in the modern world. We will have a Q&A section towards the end, so if you do have questions as we go through, please feel free to add them into the Q&A section, and we will examine them at the end of the presentation. So as we talk about 3 key initiatives to secure remote users, we have to ask ourselves why we're talking about remote users. And of course, it's not just remote users, as we'll see, but I think as we go through, we'll determine that we can start to think of everybody as a remote user, and we'll see how that works. So what are we going to cover today? So we're going to cover the 3 key initiatives. The first is SASE, or the Secure Access Service Edge, which is a new term that you may have heard from Gartner. SASE allows you to reduce IT cost and complexity, to deliver a great user experience for everyone, and to reduce business risk. That relies on a number of different things, one of which is traffic inspection at scale. And it's important that you're able to inspect all traffic, and we'll discuss how that works. Again, improving the user experience is important because people who don't have a good user experience will often do what it is that they can to get around a poor user experience, even if that means making things less secure. And ideally, we want a good user experience and security. And we're going to include roaming users as well in all of that. We're going to be looking at applying business and security policy. We're going to do that consistently for all users everywhere so that policy does, in fact, follow the user. So we're going to go ahead and look at those 3 things. But first, we're going to take a quick look at the old way of doing things. So this model is the one that we're all used to. It's typically referred to as a hub and spoke network. And when we start to look at traffic, we have the outbound gateway. So when you're thinking of your users going out to the internet, you often had to put them through a number of different security appliances to make sure that that traffic was secure. The data center served as the center of gravity in this, and you probably had more than one data center. Typically, they're going to be region dependent, but you can have as many as necessary. And then when you wanted to secure those users coming back, you had to look at creating a similar gateway for their inbound traffic. And throughout all of this, you're effectively backhauling traffic. You're sending all of the traffic through multiple point solutions in these particular stacks in both directions, and it makes for a very poor user experience, if not a more secure one, because of course you can control everything in this scenario. All the traffic comes back to that center of gravity, and the users are forced to go through it, and you can manage everything somewhat centrally, even if you can't do it in a single pane of glass. The issues with this start very soon after building it. You have to refresh all of these devices every 3 years. You have to constantly upgrade them as you add more users and things like that. And technically, people, by being given logical network access in these scenarios, could start to poke around. The old adage that the security problems you face are often from internal people tends to be more interesting when you also give them access to pretty much everything. So we're going to start to look at a different way of doing things. So when we look at that, we have to look at what's driving us away from that old model. So the first is the user experience. And I'm going to talk about this quite a bit because being able to improve the user experience by giving people direct access to what they need over the internet is something of a game changer. The costs of looking at a hub and spoke network, as we've seen previously, those can be fairly large. And of course, having to connect all that via things like MPLS tends also to be expensive. And then of course, as trends continue, you want to be as agile as possible. You want to allow people to work from home, people travel, but you also have to have the underlying security aspect of this. And it's important that when we start to look at what's taking us away from that, that we consider all of these things. So where do these imperatives come from? So typically, users are the driving force at the beginning. So I'm lucky enough that I have 1 gigabit fiber to my flat. And for me, working at home is often faster than working in the office. If I sit in the office, I'm sharing my connection, which is probably not 1 gig, with the rest of my colleagues, and we're all vying for a certain amount of bandwidth. So I can do more quickly at home. Chief executive officers and other CXO types are often very well within their rights to understand why things take so long. They want to be able to make sure that people can access things like Office 365, they can access applications in the cloud, and they don't necessarily want to centralize everything anymore. They want to be able to give people access to the things that they need to do their work regardless of where they are. And then of course, as we've talked about, we do have the underlying security concern. When you backhaul all of your traffic to a series of central stacks, you can get security, but again, it's at the cost of several other things. And the board wants to make sure that we're secure, but that things are also running smoothly and that people can do what it is that they need to do. Of course, where the board is concerned, things like security assessments are very important. Having internet security assessments, having external attack surface assessments, all of these things are driven by the desire to be secure and to stay out of the news, to avoid ransomware, all of those things that have tended to happen today. Additional trends, things like key technologies that are moving us towards digital transformation. Obviously, the cloud is the biggest one these days. It allows you to do things at a scale heretofore unknown. You can start to do things like Lambda in AWS, where you can deploy code, you can spin up virtual machines, you can do auto scaling, you can have all sorts of advantages in the public cloud that you otherwise wouldn't be able to do in an internal network. Users are moving away from offices. As I've mentioned, working at home is becoming more common. Being able to work while you're traveling, sitting in an airport, sitting in a coffee shop, et cetera, et cetera. And then also devices themselves are actually becoming things on the network. They themselves are often talking more back and forth to each other, back and forth to users than even the users themselves. And as we start to build out this new digital transformation that everybody's going towards, the internet becomes the underlying network because that is the common platform that we all share. And so the question becomes, when I have clouds, when I have IoT, industrial IoT, my workforce moving away, my applications and servers moving into the cloud, how do I secure this new world? What does this new world actually require? And so the first of those is going to be SASE. SASE has a specific definition, which we're going to see now. SASE is a modern cloud architecture for connecting users and devices to applications over the internet. Businesses have an imperative to be more competitive. You have better apps in many cases, or better infrastructure for applications in the cloud. The cloud, again, allows you to do things like auto scaling, taking advantage of the ability to spin things up and down at your whim. The internet is the underlying platform for all of this. People work everywhere. SASE allows you to be fast. The cloud is distributed, so when you connect to something, you're connecting over the internet directly to that thing rather than backhauling through the corporate network, for instance. So rather than hairpinning all of your traffic, you can go direct. It allows you to be agile at your branches, for instance. So rather than having to replicate that same stack of security appliances for both inbound and outbound at a potential 10 to 100 person office, you can do more with less equipment by putting things like security in the cloud, including things like zero trust network access, which is another component of secure access service edge, as we would see. And then, of course, being able to do all of this securely. That requires things like SSL inspection at scale. SSL inspection, the idea of examining encrypted traffic for the purposes of business and security policy, is not a new concept, but at the same time, it is something that's increasing all the time. As we go through, we will see that traffic that is inspected, rather encrypted, is going up significantly over time. There are several organizations out there who are attempting to get to 100% of traffic encrypted. And it's important to be able to examine that traffic from a corporate perspective while still maintaining privacy where appropriate. And that balance has to be maintained at a scale that can only be done in the cloud. And Gartner has essentially said that legacy perimeter security simply won't work and won't scale for the requirements of digital business and digital government. And that's true, and we're going to continue to see how that works. Gartner has published a paper called Secure Access Service Edge. The actual title is The Future of Network Security is in the Cloud. And there are 3 important things that you should be looking for from your vendor. So the first is going to be compute power at the edge, so that the computing and the security is closest to each endpoint. The second thing is, again, the agility for things like branches, where you can essentially route traffic to the internet and still have it be secure without having to duplicate unnecessary stacks of hardware at each of those particular locations. And then again, inline encrypted traffic inspection at scale, the ability to handle outbound traffic, the ability to handle the inspection of that traffic at scale, and even the ability to broker connections properly for what we would consider inbound traffic for users accessing things in the data center and or in the cloud without having to hairpin them and or give them logical access. And throughout all of this, you don't want to have a second cloud provider essentially running the backbone. And that's the difference between what's known as a service edge and a destination cloud. And that's what we're going to talk about now. So when we start to look at what a service edge is, what a destination cloud is, we're going to start with destination cloud. So effectively, if you're looking at how traffic goes out in a destination cloud, the traffic starts from the end user. It will go to what's typically known as a front door. It will then go to the respective compute, perhaps then go to the provider that it's actually destined for, only to then get to the service that you're trying to use. And as you can see from this particular picture, there are at least 5 hops in this scenario. So that adds latency, the user experience gets worse, and additionally, once you hit that front door, you as the interested party lose the ability to have any control over routing. You have the inability to see what's going on past that front door. And as you can see from the diagram here, we're looking at an additional 4 hops from the front door to the edge destination. So we can compare and contrast that with what's known as a service edge cloud. So when we start to look at a service edge cloud, the idea is to keep the compute as close to the user as possible. So you can connect to something directly that then takes you to the end provider and then the service. And it's a significantly better picture because it allows you the full visibility that you need, the control that you need, and you don't lose the ability to prioritize things. You don't lose the ability to see where things are going because you can go directly to the end. This allows all users everywhere to enjoy quick and consistent policy and security with full visibility for the IT department. And so how does this sort of thing work? Why do we care about what a destination cloud is versus a service edge cloud? Well, it comes down to architecture. When we start to think about this, what we're doing in the destination cloud slide is we're effectively spreading out the architecture as opposed to providing a cloud scale architecture that's close to the user. And that effectively makes things slower and again reduces visibility. Whereas with a proper architecture, you have a number of different things that you can do all at once. So when we start to look at SASE architecture, we're going to look at this in terms of 4 components. So the first is going to be your proxy architecture. That allows you to do things like SSL inspection at scale. As I mentioned earlier, the idea of going to a 100% encrypted internet is something that people are vying for. We probably won't get to 100%, but we'll get pretty close. And in fact, in many of the customers that I've worked in, I've seen upwards of 95, 96% encrypted traffic. And if you can't look at that traffic, if you can't inspect that traffic, then you can't apply business or security policy to that traffic. And it's important to be able to do that. And as people use the internet more and more, you're going to see more and more encrypted traffic. The second piece is that you have to have a multi-tenant architecture. And it's the idea of being able to provide an architecture that is designed for the cloud, as opposed to taking, say, virtual devices and sticking them in the cloud and subjecting them to things like a front door. So when we talk about a cloud-first architecture, it helps accelerate cloud adoption. It makes things frictionless. It allows your users to connect through closest to where they are. It becomes more transparent to the end user, and it allows you to standardize policy and things like security as you go through from a central console with the IT department. From there, we look at things like zero trust network access. Zero trust network access essentially says that I want to allow my users to connect to what I consider to be secure resources over the internet. These resources can live in the data center, they could live in the public cloud, but they are considered internal resources. This allows you to connect the users over the internet securely without having to give them logical network access. You can think about this effectively as a remote access VPN alternative without the drawbacks of a typical remote access VPN. This also allows you to reduce your attack surface significantly. In the zero trust network access world, IP addresses and things like that tend to go away from the overall perspective. You're not publishing things because your users can connect via outbound connections through micro-segmented tunnels over the internet securely. And effectively, all of your resources, which can be fully accessed by your users, are no longer published as such. What you can't see, you can't attack. And so a zero attack surface allows you to be more secure while still providing better access to your users. And SASE as a whole allows you to reduce cost and complexity. It flips the security model essentially. Rather than backhauling everybody, you're allowing them to go direct and to go over the internet securely. It delivers a much better user experience because now I can connect to Office 365, I can connect to internal resources. I can do all of that securely over the internet. And it reduces risk. I've already talked about the zero attack surface piece of that, but SASE is designed to address the unique challenges of risk in a business. Applications being spread out, users being spread out. Security becomes a function of everything that people do by default. So we don't have the user experience conflicting with the security experience anymore. So when we start to talk about users, we start to talk about securing remote users, we're going to begin to think eventually of all users as remote. So when we look at doing this at scale, we have to look at things like traffic inspection at scale. So if we very quickly again look at the old model, it's very difficult to scale this, as I mentioned earlier. You have all of these security appliances, you have to have management. On top of all of that, you have to be able to scale it geographically, and you have to be able to scale it for branch offices and things like that. It doesn't necessarily lend itself to scalability by default. If you go to the SASE model, if you work with a vendor that provides cloud architecture and a true cloud architecture, then you can start to do things where you can take advantage of the cloud scale. You have full traffic inspection without latency. If we look at the old model, we're talking about traditional service chaining in those stacks. You have different vendors, different UIs, different policies. You have to set things up for your antivirus versus your sandbox versus your DLP. And your packets get sent through each of these, adding latency along the way. When you start to look at your cloud proxy architecture, however, you can typically consolidate on one vendor. You'll have one UI, a single pane of glass in the truest sense, and all of the flows and all of the packets can be acted on in real time with the appropriate architecture. It's done in memory, at speed, without having to make copies. And the appropriate architecture allows you to scan everything all of the time. And that's important because you want to reduce the latency. You don't want your users to have to be waiting for service chaining. You don't want your You don't want to have your users waiting for a front door to communicate with compute somewhere else and have that compute service chain through a number of cloud-enabled VMs that then slow everything down. You want to do it at the edge, in real time, by providing something that scans all of the traffic, first by inspecting SSL, and then by providing all of the other features all at once. This creates a predictability for the organization. This creates a predictability as they increase the various offerings they may want. And it allows people to enjoy the user experience, again, no longer conflicting with security. So when we start to look at how this works, we have to look at a holistic picture. Security picture isn't just doing certain things. We also have to consider not only traffic inspection at scale, but making sure that the users get the full experience from end to end. And traffic inspection at scale is a large part of that. But when you look for SASE, when you look for moving your security to the cloud, you want a vendor who has the ability to do interoperability for things that they themselves don't necessarily handle. So when you talk about users, remote users, mobile users, they're still going to have endpoints and you're still going to need endpoint protection. So it's important that you work with vendors who have the ability to interoperate with various providers like CrowdStrike and Carbon Black, for instance. Things like identity management becomes important when you're talking about this. As we move to the SASE model, the Zero Trust Network Access model, we start to move away from logical network access, from thinking of things in terms of VLANs and things like that, to users and context. And identity management is an important part of that. Security operations need to be able to tie into all of this. So you need to have the organization and the SOC just as involved in all of this. There are obviously a number of different stakeholders, but security is a big one. The ability to get this information not only in a cloud vendor's portal, but to be able to take that information out, to cross-correlate it with other things that you have within the organization, and to be able to provide things like SIEM access, closed-loop integration for things like cloud application security, for security orchestration, automation, and response. All of that needs to be able to be done within the security operations function of the organization. And then finally, as we've discussed, branch networking. You want to move to a model where your branch goes essentially direct to the internet. Potentially things like SD-WAN. You want to be able to use SD-WAN at the branch, have the SD-WAN handle east-west traffic, for instance, and have north-south traffic secured through your cloud provider, through the digital services exchange that allows you to do consistent security policy, consistent business policy as your users go to the internet and as you bring them in to your resources. This allows us to start to look at IT as an enabler of the business. Most organizations tend to think of IT as a cost center. And obviously, while there is cost, as we move to a cloud-enabled model, we can start to take advantage of economies of scale, which is what's driving the cloud in the first place. So we can start to look at network transformation, the idea that even if your users are sitting in a fixed location, you can start to think of them as potentially remote users. We can start to look at network cost savings through things like reduction in MPLS and going directly to the internet, or the addition of SD-WAN. Application transformation allows you to, again, take advantage of cloud and economies of scale so that you can move code into the cloud, so that you can move servers into the cloud as you need to. It simplifies IT, and it allows your users and your developers, more importantly, not necessarily more importantly, but just as importantly, to be able to take advantage of all of this. And of course, underpinning all of this, as we've seen throughout, is the idea of security transformation. It needs to be policy-based, it needs to be as transparent to the users as possible, and it needs to be standardized and follow the users, and that's important. So when we consider all of that, that last point then becomes the next topic we look at. So consistent policy management and application. So what does it mean to have consistent policy management and application? Again, having a digital services exchange, we need to be able to block the bad and protect the good. We need to be able to do this based on identity. We need to be able to do it regardless of where the user is coming from. And it allows us to look at a number of use cases that we're going to examine now. So when I talk about business policy, I want to make it clear what business policy is. Effectively, that's things like, do I allow gambling at work? That's slightly different from, say, things like security policy, which is antivirus and things like that. When we look at the use cases, we can start to look at ensuring that users have proper access to things like Office 365, where we can provide priority to make sure that Office 365 traffic is better accessed than things like YouTube, for instance. Not to say that you wouldn't necessarily want to access YouTube, but you want to make sure that users can work before they can watch cat videos. Again, things like branches, going to secure SD-WAN, bringing my branches to direct internet access, handling east-west through SD-WAN while still securing the outbound SD-WAN traffic. Also allows you to look at things like threat protection. Again, inspecting traffic at scale, taking advantage of the cloud effect, making sure that your cloud proxy and security vendor can apply security updates that take advantage of seeing things on one side of the globe and immediately applying them to everything else everywhere else. And then things like data protection, wherein you can do shadow IT discovery, shadow IoT discovery, things like DLP, where you are actually allowing for the protection of private information and things like that. And it should be a platform. That platform should allow you to underpin security while also doing things like threat prevention, access control, and data protection, as I've mentioned. And if we look at how this platform should work ideally, effectively, again, considering your workforce, they can be pretty much anywhere. They should be able to take advantage of inbound and outbound security, access to resources that you consider internal while still being secure, and again, not over your network, but over the internet. And then you can also start to look at involving business partners in this scenario as well, and even potentially eventually customers too. And all of that is done with full visibility, monitoring of all of this in a centralized location, while also taking advantage of the number of data centers or a number of data centers around the world that then allow you to do edge computing as opposed to doing things in the cloud. So what are the things that you want to look for from a vendor in order to be able to give you all of these things? The first is that you want the business to be more agile and competitive. So you want to accelerate cloud adoption and make things as frictionless as possible. You want to be able to increase the company's use of things like digital technologies to make sure that you move to a model that is user and context-based with policy following the user, and to be able to inspect traffic at scale. We want to eliminate the conflict between the user experience and security. You want to avoid backhauling traffic through centralized stacks. And you want to be able to move to the use of a SASE architecture. Finally, from there, you also want to reduce costs and to ensure future cost avoidance. Moving to the cloud allows you to get to predictable costs, and you can consolidate and simplify your IT. And as one of our customers has mentioned, it is a rare occasion in history where things got more secure, better, and cheaper all at once, but it is happening, and this will allow you to start to examine some of those things. So when we look at this from an overall perspective, we have the old world. Life was somewhat simple, but not really. Realistically, you had to deal with all of this stuff. You had to backhaul all of your traffic. All of that goes away as the internet becomes the corporate network. You can't control the internet, but you can secure your users, you can secure your resources, and you can provide a better user experience at the same time. So when we look at the 3 key initiatives to secure your remote users in the modern world, we discussed the SASE architecture, the idea of reducing cost and complexity, delivering a great user experience while reducing risk to the business. We looked at traffic inspection at scale, making sure that you're inspecting all of the traffic, including the SSL traffic, while still maintaining privacy. Being able to move to a light branch model and or securing all roaming users with consistent business policy, consistent security policy that follows the user. And at this point, we are going to start taking some Q&A. Okay, so the first question we have is, what is the actual process for moving to a setup like this? So the first thing to think about is that this is not something that you do overnight. There are no organizations who move to the cloud strictly in an overnight fashion. This is something that, like any IT initiative, has to be planned with the appropriate relevant stakeholders. We tend to start with business objectives. We look at what it is that the business is trying to accomplish. And we talk about the things that we've just discussed throughout this presentation, but it also has to map to real-world business requirements. And that's the first thing that we typically do. From there, we will look at something like an architecture workshop. Architecture workshop is a meeting typically 3 to 4 hours long, sometimes longer, sometimes a little less, depending on the business requirements, where the relevant stakeholders will get together and will examine the idea of taking those requirements and mapping them to specific technologies. The output of that is what's known as a high-level design. And the high-level design goes to the customer, and the customer reviews it. The customer then decides that is exactly what they want, and then it moves into what's known as a low-level design. The low-level design effectively allows you to get into the nitty-gritty, the idea of forwarding traffic and user identity and things like that. And then as the process continues, we also look at what's known as customer success, where customer success is an ongoing relationship that you have that then enables you to track the progress of the business objectives against the high-level and low-level designs to make sure that you are getting what it is that you're trying to do. And it's not a one-time thing. It is an ongoing relationship that you should have with your vendor, with your cloud provider, so that you can, as we mentioned earlier on that slide, do the network transformation, do the security transformation, and make it so that IT does become an enabler of the business as well. Another question we have here, do I need to get rid of my VPN in order to set this up? Again, nothing is going to happen overnight. You're not going to get rid of your VPN right away. But at the same time, people are starting to run into the limits of VPN in many cases, especially recently. VPNs obviously work well. You're not going to get rid of it overnight, but when you start to look at things like zero trust network access, the security benefits, the policy benefits, the idea of moving to a user-centric world very quickly will generally make organizations who want to look at alternatives, because those alternatives allow you to do things securely based on policy over the internet without having to backhaul traffic, without having to worry about whether the number of users working from home will exceed the number of licenses and things like that. So, okay, let's see if we have any additional questions. Those are the two questions we've had so far. So at this point, typically the next steps, generally you're going to want to meet with your vendor. The vendor will sort of map out business requirements, as I mentioned. That's an important step. It's not just about technology. It's obviously a very important part, but it has to coincide with what it is that your organization wants to do from a business perspective. Again, things like architecture workshops, wherein we will meet with you, map those business objectives to technologies, to the ability to use technology to accomplish particular goals. And then we also have things like executive briefings, wherein executives from your organization can come out to our offices in San Jose. They can meet with our executives. Obviously, our executives travel as well, so we can arrange for things to be done in region as need be. And being able to do all of these things will allow you to move to a more agile model while still securing your remote users securing pretty much everyone through consistent policy that, again, follows the user. So at that point, I would like to thank you all very much for your time. It has been a pleasure to be able to speak with you today, to be able to cover these topics, and to introduce you to these. We will have additional webinars over the course of the next few weeks, and I invite you to visit the Zscaler website as well as follow the webinars so that we can introduce you to further deeper dives on these topics as we go through. Thank you very much.